Welcome back to Advent of Code 2021. Today we are working on day 15. Let's just get started. So there is a strange animal that we're talking about, and it's this one. And I would recommend you to check the Wikipedia page because that's a weird animal. That's it for the for the fun fact here. I actually don't have a fun fact for this specific animal, but yeah, let's just dive right in and actually start. We copy paste the input, we take our template that is in the GitHub repository, actually use it here, day 15. I always say I need to add a trimming here, so here it is. We split by line. Now, because we do trim here, we don't need to remove the empty lines here for the map. We could keep each line as a string, but I think it's better to actually have a list of numbers. So here we're going to call that matrix, or we can call that map because this is a map. And we are gonna log that because the first thing we do, as always, as every day in this challenge, we are making sure the input is parsed correctly. So node day 15.js, and here this is a good time to use the node console.table, to output a nicely formatted outputs. That's a hack that someone suggested in the comments. If you have some nice hacks or some questions, don't hesitate to drop a comment. I'm reading them all and replying to most of them. Okay, so yeah, nothing crazy here. Nothing crazy. What we need to do is to find a path between the top left and the bottom right positions. So const from is going to be x0, y0, and const 2 is equal x should be map. Map of map dot length. So here x, actually here x is just map dot length -1, and y, do we know if this is like a square, this thing? I have no idea. Resembles a square. Okay, so that should be good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 8, 9, 10. Okay, so we can say this is a square, so we can just say this is the x and the y of the goal. We need to go from this position to this position here. And as you see, we have a map that we need to navigate, and we need to find the best path in this map, which means we need a path finding algorithm. And there are a bunch, but one very popular is the Dijkstra algorithm that I've already checked right before the stream. And Dijkstra algorithm is basically just taking a lot of, actually I haven't read that correctly, so we actually are going to be using that, implementing that, and yeah, that's the challenge. So what I like to do usually when I implement from pseudocode is just use the code, paste it here, and go line by line. So here we're going to create a function that's called find path between what's the graph? Graph is going to be the map, and what's source? Actually, here we don't need a function because we're just going to be implementing this inside here. So here we have something that is called create vertex set queue. And the queue is not empty. Oh, I'm not really liking this pseudocode syntax here. We store infinity in distance v. Okay. So we need the array dist, the array prev, and q is some kind of a queue. Vertex set. I don't know if vertex set if this is a queue or not. Here we say, okay, the vertex in the queue with the minimal distance. Okay. So that's going to be fun to implement. Maybe I'm not going to be implementing that perfectly at first, but yeah, let's just do that. So here we're going to say const queue equal an empty array. Let's do an array for now for this queue here. Then for each vertex, let's actually give, you know what, we're going to take that, paste that in here. It'll be a lot easier to implement the algorithm. So for each vertex v in graph, so here we need to do a double for loop. I between map for j map of ij, this is the current element. What do we need to do? We need actually to create const distance is an array. Actually, so here we can one thing I don't like is we need to do map from a point to a specific value, and we can use an array. Actually. The array, we need to just have map.length times map.length to store all the coordinates, and then we just need to do some kind of manipulation. So here we're going to create a function index x, y. So we're going to return and map, because we need to return x plus y times map.length. I think that should be fine. So the last value, so if we take the first value, it's 0, 0, so it returns 0, and if we take the last value, it is that plus that times map.length. So that is map.length squared minus map.length. I'm just trying to compute that by hand just to make sure we are doing something correct. So this is map.length times map.length minus 1. Okay, so we have, I was just computing what this function would give us. So that should be good. So basically here, instead of having a matrix, we could have had a matrix, but yeah, we have just a single dimension array, and here we can fill that with infinity, because in JavaScript there is a value called infinity. We need the same thing that's called previous, and here we fill with null. I think it's better than undefined in JavaScript. And here we just need to add v to q. So yeah, in q we're just gonna create an array. We're just gonna do the same. So here we're not gonna be needing this double for loop actually. We're doing the same. So here we fill with zeros, and then we map x index, and we store the index here. So basically this is the simple way to create an array in JavaScript, starting from 0 and going all the way to the length of the array minus 1. I'm just going to show you an example. Array of 10, let's say. Here you have to fill with zeros. That's really important, otherwise the array has undefined values. So here if you map x, I, and you just return I, you see it returns 0 to 9. That's exactly what we need. So that's perfect. We are doing good here. So here we say coordinates to index, and we create another function that's index to coordinates. That's something that I've used already in the past. So instead of having two-dimensional arrays here, that's sometimes a bit hard to manipulate. I just store things in a one-dimensional array, but then you need to, from x and y, get the index inside this array, and from an index inside this array, get the x and y. So here we're just going to say we have the index here, and so here we need to return x and y, and const x is equal index modulo map.length, I believe. Yes, because here you always multiply y by map.length, so that should be correct. And here const y equal index minus x divided by map.length, and that should give us our x and y here. Okay, so that's a little bit of utils function that's going to be useful for us. Here we say while q is not empty. So here let's do that. While q length is above 0. So maybe there's already some implementation in JavaScript, but I think that would be kind of cheating. Here we really would like to understand a bit more this Dijkstra algorithm, and the best way is to take the pseudocode and re-implement it yourself. Maybe I will find some bugs in my code so I can understand the algorithm better. Yeah, that's, to me, the most fun, to still learn something, to reuse something that someone thought about, but still learn something at the same time. Okay, so here we have u. So, okay, const u. Here we need to find the vertex with the minimum distance u. So here we're going to say let min infinity, let min index equal -1, and here we do for loop over the, we start with I, and we do for loop over the array dist. No, we need to do for loop over the array q, my bad, q. And what we need is we say if dist of, so here we store indexes, so that's perfect. We just need to say dist of elements is below min. Then you say min equal dist elements and min index equal elements. Actually, I'm gonna change that. We're gonna say index here, because in Q we don't store the coordinates. Remember, we store an index. The index inside the array dist and prev, and in order, yeah, I think that's just it. We are good here. Let me know if you have some question about the implementation, but like I'm feeling we're good for now. We need to remove U from Q. So here, because we have an array, we need to do something using slice or splice, and I never know how to use this correctly. So we're gonna have to do some magic here. So const U equal, actually we don't have the index inside Q. There's too many indexes. So here, let's rename that element. Otherwise, it's super confusing. So here, what we need is not the element here. We need actually the I. Because we are going to be using, we're going to say q.splice. And actually, there is everything we need here. And here we need I. And we delete actually one element. So that should be fine. So actually we can try here. We have an array. So we're going to say let A equal 1, 2, 3. Let's say we want to remove the value 2. So we should say A dot splice 1, 1. We have just the value 2 here, and A is the value 1 and 3. So here, instead of having U, we see that splice is returning an array, as you see here. So we need to use like that, so that we extract just the one value inside the array. Okay, we are good. And actually here, there is an issue. So here we're going to say the min index is 0. Yeah, I should do that. Okay, so now we need the neighbor function. We need to know the neighbor of V. Okay, so here we need to do for each neighbor. So we need 4. We can have 4 neighbors. So we need to do, well, how we do that? We create an array of neighbors. Get neighbors of index and map. We're going to create a function here. It's always good to have a function, get neighbors, index and map. So const coordinates, we do index to coordinates, index. So now we have something, we have coordinates x and y. So actually we can say x, y. We say so we could do something like that, return x minus 1, y, x plus 1, y, and then y minus 1 and y plus 1. That should give us the 4 neighbors, except there could be neighbors that are outside of the array, so we're just going to filter that. I'm gonna say n is above 0. Oh wait, here we can use x and y. We're gonna say x is above 0, y is above 0. Oh, there is a mistake here. I need to click that. Okay, x should be above 0, y should be above 0, x should be below mapped length, and y should be below map dot length. So here we should have the neighbors, the correct neighbors. So one thing would be nice would be to actually display neighbors. Oh, actually, do we want neighbors as coordinate x, y, or do we want neighbors as indexes? We're just going to say const oh, here we need to actually do the for of I never know how to write that correctly, and I know this is the US version and there is an English version as well for this, so yeah, that's funny. As you know, I'm French, so that's always funny when I read this. And you always have to write that when you're like doing pathfinding. You have to write that so often. Okay, so let's stay focused. We need alt. What is alt? I don't know, maybe it's an alternative. So let's say const alt. Let's just write alt for now. And we need the distance u. So this is dist u. So here u is q, it's an index to the distance array, so we are good, plus the length between u and v, v being the neighbor here. I called it neighbor. And here the distance, so that's one thing that's important to know. Here, when we are here, we're going to say the distance between here and there is the value that is actually here. And so if you are at 3 here, it costs 8 to go to this position, or it costs 1 to go to this position. I think we're going to do that. That's going to be simpler. We're just going to have to add the cost of the start point. It's quite important. So now we need to actually do I need to get the map. Oh, because that's going to be annoying. We need to say const coordinates. We need to say index to coordinates of neighbor. And now we can do map of, actually here, let's say xy, map of y of x. I believe this is how we should be doing, yeah, y and x. Okay. Yeah, so our x is from here to here, and the y is from top to the bottom. That's why we're doing it that way. So we should be good here. And now we need to say, okay, if alternative is lower than distance of v, v being neighbor here, in that case we do this is equal to alt and prev of neighbor is equal to u. Okay, let's display here. Yeah, that should be the wall. Oh no, that's a while loop. So here we're going to display prev, and because now that we've implemented that, we've created a matrix, and now we need actually here, if you are only interested in the shortest path between source and target, can terminate in line 15. For now, let's just not do that. We're gonna have to do that afterwards. So that's a lot of stuff here going on. So we're gonna just display those two arrays, and we're gonna see already, is that thing running or is that thing not running. So as you can see, there is already a bug. So we're gonna go in debug mode. I is not defined here. Yes, that is not I. We store the value I in min index, so this is what we actually need to use. I is still not defined here because this min index still. This is this U. Min index is the index inside Q, so I think here we need to use U. Get neighbors U. Yes. Yes, that's the correct way to go. Property length of undefined. Index to coordinate. Okay, here I'm never passing the map. I should be. I believe here I'm not passing the map as well. Yep, that should be it. Not a number of undefined. Okay. If we want to log this, we're gonna log x, y, and then we're gonna log the map. Actually, we're not going to be logging the map because it looks like this is not working fine. So we have like an issue in the code. Not a number. Okay, so already here we have not a number. So here we're going to log the neighbors. Neighbors starts with an empty array, and then it starts with just 1, 1. I don't know why. Where is that? U0. There is no neighbor? Seriously? Let me make sure. Oh, here this is not exactly. I need to make sure x equals 0 and y equals 0 is working. So that was most likely the bug. That's the typical off by 1 errors that happen sometime. Okay, so here for u equals 0, we have actually two neighbors, which is the neighbors to the right and the neighbors to the bottom. U equals 0 is this one, so we should have this and this. That's perfect. So this is working fine, but then here this is not working fine. So I think index to coordinates might be just like messed up. So we're going to be logging index x and y, and we're going to see what is up. Actually, I really liked this little debugging trick, is to put parentheses around the variables that you print so that they are labeled like that here. So that's correct. Here index, and then okay, so here index is a coordinate. So that is why this is just not working. What's up with that? So neighbor here is already an X and a Y. So actually here, neighbor index equal coordinates to index, and we have the neighbor and the map, so that's the right way to go. So here, instead of having a neighbor here, we should use the neighbor index. And let's see, that should be fine now. Just like, no, not fine yet. Coordinates to index. Oh, right, coordinates to index. Are we using that several times? No, we're just using that once. So actually here, we're just going to do that, which means that we need to pass an object that has an X and a Y and a map. That should be a little bit simpler. Y is not defined. Okay, so here, oh yeah, Y is actually neighbor dot Y and neighbor dot X. That should be correct now. We have a lot of infinity, which means that the algorithm didn't really do its work. Here, dist neighbor index. Okay, we have an issue. So here we're going to be logging. So here we're going to break, because we want to just see what's happening on the first iteration of the algorithm. And here we're going to display neighbor index and alt. Let's see. Neighbor index 1 alt infinity. Oh, could there be something? Neighbor index 10. Oh yeah, 10 is the one here. Alt is equal infinity. So there is definitely an issue here. Dist of u. Okay, the distance of u. I think I haven't set this up at the beginning, which is we start from. So basically, dist of 0 is equal to map 0, 0, which is the distance for the first point. It's equal to 1, because this is the point that we are on and it's defined already. So I think this is something that wasn't in the algorithm, was it? Oh, dist. Okay, we missed this line, this specific line. So that's really good that we found. The distance to the source is 0, but for in our case, it's not exactly 0, because we already have to say, okay, this is 1. So yeah, that's great. Now we have something that's working. The array is starting to fill, so I can remove the break here. I'm gonna remove some console logs, otherwise that's gonna fill our screen with information, and in the end we have our full array filled, so we know exactly how much time it takes to go to any place. And in our particular case, I believe we want to go to the last spot on the bottom right, and total risk for this path is 40. So you don't need to count the start. Top left position. Okay, don't count the risk level of your starting position unless you enter it. Okay. So actually here we need to just store 0, because just need to store 0, and here at the last position we have 40, so that is all that we need, I believe. So here we don't need to do this work of finding the full path, because we just care about the cost, the minimum cost, and the minimum cost we can find it in the array at the last position. So if we want to do that correctly, we can log dist of coordinates index, and here we go to and map. If you remember, to is something that I've defined here. Actually, the from we don't need, but the to, this is the last position of the array. And yep, basically if we do that, too much output. How come? Let's remove all the console logs. Clean a little bit the code. And yeah, now we just have one. It's perfect. We can remove this as well because we won't be needing it. We can remove this pseudocode that we've, I believe, implemented correctly. Now we have 40. Let's check if we have another issue somewhere in our code. If this is quick enough. Wait. Okay. This is a little bit slow. We've seen that, but I'm not worried for part 2. I mean, let's see part 2. First of all, let's celebrate for part 1, and now let's go to part 2. I'm going to read that briefly. Okay, so that's interesting. What we have is we need to duplicate and make a much bigger map. Interesting. And we need to change actually a couple of things. So we are going to do that. So every time we repeat that's going to be interesting. So first of all, we need to create a map, I believe. That's going to be quite huge because here we have like this big thing. So that's going to be huge. So we're just going to be taking the we're actually going to take this input, which I believe is the input that is here. So that's correct. So we're taking again the small input, and we're going to have to do some magic on this input to make a much bigger map. So const actually const bigger map is equal an array of, is it 5 times? 5 times, okay. So first of all, we're creating a big map. So here it needs to be 5 times map.length, and we fill with zeros first, and then we map, and we need to create an array that's so this is the x here. So here we don't care about this value, and this is, sorry, this is each line. So the index here is the y, and now we need to do something similar here. An array of 5 times map.length, because we know this is a square. Oh my god. And we fill with zeros. And why do I always fill with zeros before doing the map? Because if you do map and you have undefined values in your array, that's just going to be messed up. So here we just fill with zeros, and then we do the actual mapping. And here we don't care about the initial value, and what we want to return x here is something, some value. And first of all, let's try to just copy the map several times. So in order to do that, we need to say const original x equal x modulo map.length const original y is the same. So here we can just return map of y. Oops, here I should have a y. Yx. And if we do that, and here we do table, oh wow, console dot table of big map, everything exploded. Couldn't read property 0 of undefined map. What do you mean property 0 of undefined? Okay, so here we're just gonna be, oh wait, I'm using x and y, but no, that's not correct. That's original y and original x. Okay, this is so big, my screen is just messing up. Let's just see for the first line, make sure we have something correct. The index, okay, we don't care about the index. We want to start here, 1, 1. And it starts with 42, and then it starts again, 1, 1, 6, 3, 7, 5. Okay, so it looks like we are doing something correct, at least. So here the table doesn't look good, so I'm gonna just be doing log of map and map, and here its position is with a line return, and here if we do that we should have, oh, not map, we actually need to use big map. Okay, it's a lot easier to read that than the console table. So as you can see, we have here, actually this map is almost like that. I just want to make sure this 1163 repeats correctly. So yeah, we have something correct. Now we need to actually increase the number. So we need to increase to the right and to the bottom. So here we need to plus something. We're going to call that offset. Const offset is equal to 0 for now. And we need to make sure if this is above 9, const value, we do that, and we say if value is above 9, in that case we return 1, otherwise we return value, because I don't think modulo would work here. So the offset, what do we do with this offset? The offset is math.floor x divided by map.length plus map.floor. Basically, we have a Manhattan distance. So here the square to the right is 1, the square to the bottom is 2, 3, 4. So yeah, that you need to add when you move 1 square to the right, you need to add 1, and when you move 1 square to the bottom, you need to add 1. So that's why here we're adding that and that. And I believe that should be fine. So as always, what I like to do is to to be honest, I don't want to compute that by head. What we need to check is here. We should have 2274. That's correct. And then it ends by 86. Here it ends by 19. Okay, so that is not correct. And at the bottom right, that looks old. Oh, wait. one thing, I think I made a mistake. They wrap back around to 1. Okay, so here instead of having 9, I need to say value minus 8, I believe. So if this is 10, it should be 1, so it should be actually minus 9. I think that's it. I think we could maybe solve that with the modulo, but I think that should be correct. Let's try that. Now it ends by 79. Okay, that's correct. And here it starts with 67. Okay, so I think we've got the right map. Now we have the map. And the trick, what I'm going to do, we're going to reuse part 1. We're going to call that solve for a specific map. Here we say solve the basic map, and then part 2 we can remove that, and here we're just going to say solve bigger map, and we can remove this debugging log, and we have 315, which I believe is the right thing. So basically we just had to create the right map and we reuse the algorithm. So here I'm a bit worried. Is it going to take a while? Is it not going to take a while? This is taking a while, so I'm not really happy about that. So what we want to do is we want to implement this little trick here, which is you can terminate the search after if u is equal to target. So here we're going to say const. Here let's rename 2 to target, and here we're going to say target index is equal coordinates to index of target on the map. So now what we can say, we say if u is equal to target index, then we not return, we break. What do we do? Yeah, we break out of this while loop. That should save a bit of time. Maybe not enough time actually. Whoa! So the thing is, I don't think it's gonna take forever. So yeah, Dijkstra is not the most optimized algorithm. So that gives us a big issue. Oh, actually, Dijkstra is not the most optimized algorithm, but we also have something here that's quite slow. Every time we are going through the full queue here. So maybe a better way would be to have a priority queue. Is that, yeah. Oh, look at that. It's actually a good thing. A priority queue. So yeah, basically to be honest, I think I'm gonna run that as well, just to make sure, like, if it runs fast enough, I'm just gonna use this thing. But so that's the problem. When you have some performance issue, you would need maybe to do some profiling, because I'm not sure exactly what takes the most time. Maybe creating the objects, doing the filtering here is taking quite a lot of time. Hehehe. And this index to coordinates and coordinate to index is also taking some time. It's not used so much. Yeah, to be honest, I feel that this is a fail for this part too because it's taking so much time. And I feel this was one reason why the part 2 was designed. So I'm gonna stop this run for now, and actually one thing I want to check is how do you do priority queues in JavaScript. I'm gonna have a quick look on the web. So the priority queue seems quite complex to implement. So what I would like to see first is see how many use we are like taking into account, just to have an idea. Looks like quite a lot is the answer. To be honest, that's one example where like I'm unclear on how to proceed, because we could rewrite everything with a star pathfinding. It has a heuristic, which means instead of having to take into account so many things, oh yeah, my internet speed is bad. So yeah. Here you can see there is quite a lot of things that aren't taken into account that Dijkstra would take into account. Should we move to A star? I'm gonna do like a little bit more research before taking this decision, because that looks like a big thing to do at that time of the day. Okay, so I still want to implement this priority queue thingy. So what we're gonna do is we're gonna use a priority queue from npm. I think JavaScript has a very small amount of dependencies, so small amount of libraries to remake our life easy. Like if you go to Python, for example, I'm sure there is a priority queue implementation. So yeah, we're just gonna be installing the priority queue. Okay, that's it. So we're gonna be doing that priority queue. So here in our solve function, the priority queue is queue itself. That's interesting. I haven't thought that completely. Okay, let me check the pseudocode implementation for the priority queue. Okay, so here you add with priority everything. Looks weird. You decrease priority. Okay, that's interesting. Can this implementation do that actually? Enqueue, dequeue. No, you cannot change the priority. Ah! Okay, my bad. Looks like today is giving me a lot of trouble. So I'm sure this is all about like some small optimization. So I can npm remove priority queue JS. I'm sure I have some optimization that I could do. The thing is, once you visited an element once, you don't need to visit it again. So here, that's why we do the splice. But splice is an expensive operation, especially if you have like, how many characters is there here? We have 10,000 characters. So if you do a splice with 10,000 characters, that's definitely expensive. To be honest, I think we have a good solution. It's just not super optimized. You know what? I just want to see if queue.length module 100 equal to 0, console log queue.length. What am I doing here? I am just trying to get a feel of the speed. So you see, we actually, is that normal that we have 250,000? Oh yeah, definitely. We have 250,000 elements. And as you can see, this is going down quite slowly. That would just need like 2 minutes to run. So I feel there is some optimization that we can do. So I want to take a second and think about optimizations now. Okay, so I've spotted one first optimization that's not super big, but the previous array that is used to reconstruct the full path is not something that we use because we just want the cost of the route. We don't need the full path. So that's one thing that isn't a speed optimization, but that's a memory optimization already. We have like something that's much lighter, so that's good, at least. Yes, but it doesn't change the speed, of course. Get neighbors, maybe we can make this a little bit faster. Can we? To be honest, I think we really should have like some kind of debug logs to see what is slow and what isn't. So I'm gonna look that. Okay, so in order to do a bit of performance deep dive, what we do is we use the flag inspect-erk, which is basically opening the opportunity for us to use the Chrome debugger. And here we use inspect and we see actually day 15. And we have our debugger open, which is really nice. That's going to be super useful. We're actually going to be using the profiler. Doing start here. And as you can see, things are moving here. And we're just going to do stop here. Still running, but we don't really care about that. We could actually just never know. post script execution, yeah. Okay. So here we see that the most time intensive thing is the solve function. Definitely, we know already about that. So I think we need bottom down chart. Oh yeah, chart, it's really nice. Solve. Does this mean we are calling the function solve several times? I think we're just calling it twice, right? So, oh wait, really nice. I didn't know about that. There, what is that? That's how much time it takes. I don't know what's on the left here. That looks really neat. Maybe it's the time, how much time it was spent on each of these operations. And whoa. If I'm not mistaken, we are spending so much time. I need to double check that this is the right, this metric means how much time we're spending in this. Let me check that. Okay, so I wasn't able to find the answer on the web, but really, I've been looking at the profiler again and the top-down view, and you see that everything, like all the work, is done in the solve function. And that's it. There's no other thing. So the work is done inside the solve function here. I mean, that's nothing new. But yeah, it seems that this is something that takes a lot of time. This finding the minimum place. So it pulls us back to the thing, I mean the splice as well here. Oh, everything is exploding here. So the splice is also an issue. Of course, it's like such a big array. So really, we need to review the data structure for Q, finding the minimum and splicing it here. That's all there is to optimize our stuff, is the data structure for Q. We have an array. We know a priority queue would be good, but we would have to, so priority queue npm, there are several, and we need to decrease priority. That's what, yes, that's what we need. We need something that has a decrease key. Okay, so this is something someone wrote, someone random on the web, and there is no... Oh, look, they wrote this because they needed a priority queue for the Dijkstra algorithm. That's insane. Okay, so I think I feel like I'm really hitting a dead end here. I am hitting a dead end. That's frustrating. So, first thing I'm thinking is that we're going to be making a hack here to not use splice, because I know this is a very time-consuming operation. So, I'm going to say const u equal q of min index. And then we could say something like q of min index equal null. And Here we just have to check that q of I is something. Also, we just have to check that element is not null and then do the rest of the stuff. So here what I'm doing is just removing the splice operation and keeping this huge array. So that's not ideal at all. Let's try that anyway. Okay, so here as you can see, this did not work because we have yeah, of course. Doesn't work. Actually, we don't care q.length. Yeah. So now I cannot this debugging here is not useful at all. We just need to do let remaining equal q.length, and then here we do remaining minus minus. That's intense. Okay, so we see things are moving. Maybe a bit faster. So let's try to do the node inspector again. Did I close? Closed everything, of course. So here we do that. Here now we do about inspect here, and let's run the profiler here. I need to wait for it to profile actually. Here, this is just running the program, taking a lot of metrics. Okay, I think that should be fine. We've got enough metrics. Now we can pause the program again, and we see that now we don't spend so much time in here. All the time we spent is here, of course. Of course. So one option would be to there's so many options, but yeah, I feel like we're just trying to optimize here, and one option would be to remove the null element at that stage here. So here we'd say here instead of const we would say let here. Here we would say let q2 if element, then we do all that like usual, and we also q2.push. Oh wait, do we care about the index here? No, we don't care about the index. q2 push element. Makes me think that instead of having of course, instead of having an array, we should have a set here. We should have a set. Now we do q.size is more than 0. We can go back to use here for debugging q.size. That's interesting. You see, like the algorithm, the stuff was not optimized. Here we do q.get. No, here we just say min index and q.remove delete you. Actually, this so here we need to go through each element. So how do you do that? For go iterate through set JavaScript. That's one thing that I haven't done yet. Set prototype.forEach. Okay, so that's what we're gonna do. Set.forEach. Oh wait, this is in French. This in English is better. I don't know what value 1, value 2 is. What the hell? Value and key, okay. But for a set, this is what? There are no keys in set. Okay, value. Okay. Cool. Okay, so actually we can stop our process here. We stop our process. This is killing this. It should be killing this debugger. It isn't. Let's focus. Here we need to do q.forEach. Here we have value, and what we need to do in here is, so this, let's forget about the q2 thingy. Here this should be a const. For each value, what do? We say if dist of value is less than min, then min equal dist.value and min index. So here we're gonna, instead of min index, we're gonna be using, no, let's use min index, and here we're gonna be using value, and that should replace all of that. Oh, let's just try to run that. Okay, this remaining is not defined. Yeah, we should remove that. This, we should remove that. This we can remove as well. Let's try to run that again. Oh, that looks so slow. Oh my god. Just went back in terms of performance. Like, I think this for each is just nuts, like super slow. Like, what the hell? I think maybe an iterator is gonna be better. Okay, set. We're just gonna do for of. Maybe a for of is gonna be slightly smaller, faster than the for each, because the for each tend to be iterator, so value of q. Now we can copy paste that in here. Let's try. That looks already faster, but so the thing is, the further we go, the faster it should be. Let's try to debug that again here. So actually, I maybe need to reopen that. And we start the profiling. Wow, this today's video is just getting out of hand, right? I'm wondering, are you still watching? If you're still watching, please write a comment saying I'm still watching, because I believe maybe I'm making a mistake by recording such a long video. Is it a mistake? Is it not a mistake? We'll see. So here we can stop. We stop this as well. Let's look here. Looks like the hot spot is still this thing here. Yeah, we're spending so much time in this. I doubt there is anything we can do that's going to be better here. So just gonna say time. We're gonna remove the debugging here. Oops. Time node date 15.js. Why is there still debugging? What did I remove? I removed the wrong line. Okay, I'm gonna just let that run and we're gonna see our Dijkstra solution. The conclusion is that really like this piece of code is not the right way to get the minimal index. Thing is, this is O of n, meaning each time, meaning n square even, because here we're going through each element of Q, and here we're going through each element of Q again, so that's n square. Whereas I believe with the priority queue, we could have O log n here. That would be n log n, which would be a lot better already. And then the next step of optimization would be to change and use a completely different algorithm. Like A star, for example. I believe that would have been a good optimization. You never know. You never know. So, yep, I'm gonna let that run for a little bit. And we'll see how much time it takes to do that. Okay, so the end result is that it took 162 seconds to run the second part, to solve the second part. So the conclusion is that Dijkstra isn't really the best algorithm. I think A star would have helped a little bit. And having a queue would have helped tremendously in JavaScript, but we don't have a queue, so we are doing O(n) square instead of O(n) log n. And yes, that's it. Maybe you have some other tips and tricks to solve part 2. I think that wasn't my best attempt, but yeah, it worked. And by the way, actually, before we end this video, we need to actually make sure this is the right answer. It is the right answer at least. So don't forget to drop a like, a comment. Don't forget to subscribe if you haven't already, and see you in the next one. Bye bye.